I'm saying like some of these topics is very important is because it's widely used by many companies, and it is always a good to have to understand these concepts and to be able to use it or control it. Okay. So now the first topic, like the topic for today that we are going to discuss here is auto scaling. What is auto scaling? So first, in our initial class, we'll understand what is auto scaling, why it is used, and where it can be used. After that, we'll talk about other things. Okay. So when we talk about auto scaling, it is basically used when you want to horizontally or vertically scale and like vertically or horizontal scaling. Okay. Uh, just a minute. Okay. Okay. So today's topic is auto scaling. So we'll start with understanding what an auto scaling is. So auto scaling has two components. First component is horizontal scale. Second component is vertical scale. Okay, remember this because these concepts are not only used in this particular tool, it can be used in other tools too. It is used in Kubernetes too. Okay, so this auto scaling not only happens in AWS but also happens in other like other tools and services too. Okay, so horizontal scaling means I have an instance. Okay, I want more capacity than this right now. Okay, example, I have I have a Mac OS system right now. Okay, which has I'll just check my configuration. Okay, 8 GB of memory. Okay, tomorrow I come and tell you that my system, my 8 GB is full. Okay, my application is pretty heavy, I am not able to sustain in this 8 GB. Can you give me more than this? Okay, so in that case, okay, what we can do is, in that case what we can do,
Scaling.
basically in that case we can increase the instance type. Okay, we can update the instance type to probably 16 GB now. Okay, that is possible. Cool. All of us agree that it is possible to update the instance type. It is possible. Okay, if you want I can show you around how it works. Okay, now second thing that we talked about is, so I have 8 GB, I need 16 GB, I increase the instance. This is vertical scaling because your instance is increasing. In your use case example, you have 250 GB disk. Okay, tomorrow you want to increase the disk, you want to increase the space. What you will do? Attach an external hard drive. Okay, when you attach an external hard drive, you are doing a vertical scaling, you are increasing the capacity of the system itself. Okay, increasing the capacity of the system. Now when I talk to you about vertical scale, there's always a limit to where a vertical scale can happen. Okay, example, I say I have 8 GB but I want 64 GB of memory right now. It's possible, but doing it is possible, but sometimes it also becomes impossible because you don't want to increase it too much. Plus when you just want memory, you increase the instance type, your CPU will also be increased. There is a possibility that your CPU you don't need that much, so you're again wasting. Okay, even if you use a memory optimized image, in that case there are still challenges. Plus in case of vertical scaling, if that machine goes down, you don't have a backup. If that machine goes down, it is down. Okay, So in these kind of situations, in some situations, we prefer doing vertical scaling. Okay. Increase, 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 increase. Okay. Increase the increase the machine. Okay. Or capacity of the machine. Now, second type is horizontal scaling. Okay. You increase the instances horizontally is what we can do. Now, when you do that, uh, when you generally do that, what happens is, like in this scenario, you have one instance. Okay. You have an application running on that instance. If your application needs specifically 16 GB, then you'll have to tell me why it needs that much GB. Okay. Is it like there is a lot of traffic coming in there? Okay. Like example, I say that at a particular time, okay, my traffic goes really high. Okay. If my traffic goes very high, then what happens is this needs more memory, because there's more traffic, there's more people, there's a high consumption, high compute I need at that particular point in time. But I only need it for that particular point in time. So what I'll do is, instead of increasing the instance, I'll increase it horizontally by bringing up another instance. Okay. And distribute the load between these two machines. Now 8 GB here, 8 GB here, 16 GB. Okay. You take 8 GB here and you take 60, you take 16, 16. You take 8, 8. So 8, 8, 16 GB you got. Okay. So now there is a machine running here. There is a application running here. There is an application running here. Okay. You can get the traffic and let it land up to any one of these. Okay. Now you'll tell me that, okay, when I bring up another instance, okay, it's going to add up to my cost. Example, if I say 8 plus 8 16, it's not 16, because all of this 8 GB will not only be consumed by your application, will be consumed by operating system too. So here also I'm spending some memory in operating system. Here also I'm doing it. When I have vertical scaling, there is only 16 GB. There is a small part that a operating system can take. Apart from that, everything I get. So only one time I'll have to spend some capacity, spend some memory there. Okay. Now this is what is there are vertical scaling, horizontal scaling. In case of a vertical scaling instance, what you can do is increase the instance type. In case of horizontal scaling, you'll do auto scaling in case of an AWS account. Now what happens in this case is, you have a configuration. You mention that I need from this much to this much instances. Example, 2 to 10. So what it can do is, it can scale from minimum 2. So minimum 2 instances is going to be there, and maximum it can be 10 instances. Now what it tries to do is try to manage the load between every one of them. Okay. Manage the load means, if load increases on this one, it sees, like AWS sees that, okay, load, CPU, memory is increasing on this one, then scale another one. If memory is increasing on this one, add another one, kind of that situation. Okay. Now we'll start doing some activity around it to see how it works. Okay. This is basically used more in cases. Example, I have i'm running um, I'm running flipkart.com. Okay. My traffic majorly comes from India region. Okay. So during business hours of India region, I might have less traffic. Why? Because people are working then. When they come back, that's when my business time is. Okay. So like basically my business time would lie around 6 a.m. India time to 12 p.m. India time. That's all. Right. 12 a.m. India time. Like no, midnight. From 6 to midnight. That's my peak time. Okay. After that, my peak time always decreases. Okay. After 12, most of the people will be on bed. They won't do shopping. There will be less people doing shopping then. Okay. What I'm trying to say is, traffic is less. From 6 to 12 also, there is going to be a peak time. Example, from around 6 p.m. when people leave their offices till 10 p.m. it is high traffic. Why? Because that's the maximum time my people are buying the product. Why? Because that's the time they come out of their offices, they start looking at Flipkart and start do all of their shopping stuff. Most of the people, I'm talking about many people, there can be people doing shopping before it, after it, in midnight, after midnight also. I'm not saying stop the website after that. Okay, what I'm trying to say is my maximum traffic comes then, because most of the people get free at that point in time. You can calculate it from your business, you can calculate it from a business matrices as to what is your peak time. I'm just taking some assumption. Okay, right now I don't know what is the peak time for Flipkart, I'm just saying. Okay, so I'm randomly taking an example here, that around 6 to 8 is my 6 to 10 is my peak time. So that's when most of the people are buying the product. So that is the time I need maximum number of instances up and running. Okay. But rest of the time, before this, after this, there is less traffic. I don't need that many instances. Example, now my Flipkart is running on 20 instances or 50 instances. There is an application called cart service, okay, or checkout service or buying service, anything. Okay, I am running it on generally I run it on 2 instances. Okay, which is the time when there is no off business hours for me generally. Okay, now as soon as it sees more traffic coming in, like traffic is increasing, and then it can come down. So when the traffic increases, 2 instances will not be enough for me. Okay, when I have peak traffic, I might need 10 instances of the uh same machine, same application running on 10 different machines. So now I need 10 machines only at the peak time. I don't need it rest of the timing. Okay, so what this auto scaling does is it reads the capacity of the system, like what is the capacity, is it increasing, it is getting used, not getting used, something. According to the matrices, it will identify whether it needs one more instance or not. Okay, and accordingly it will keep on adding, upscaling and downscaling the instances. Now when I say upscaling and downscaling, example, I have a MongoDB. Okay, um maximum my people try to hit that MongoDB around maybe um 12, after 12 p.m., like as in noon, 12 noon till 6 is my peak time. That's when people are hitting it maximum. Okay, peak time can be very small also, like 3 to 4 is my peak time. But it's my peak, as in peak. It's not exponential peak. It can stay on the peak for some time and then come down. It can come down initially, something like that. So this is my peak time. After my peak time, I need 10 instances. Right now, I just need 2 or 3 MongoDB backups and instances running in the cluster. That is fine for me. So in that case, what I'll do is I'll add some auto scaling concept in picture, which will automatically scale it up when it needs it and brings it down. So this is already coded. Okay. What I want to do is automatically bring the number of instances and bring down number of instances based on the capacity, based on the traffic, based on the usage. Why? Because I don't want to keep everything running like 10 instances running 24/7, because I'll have to pay for 10 instances then. Although there's not traffic also there. Plus I'm just wasting my capacity. So in that case, what I generally do is I use auto scaling. I have minimum 2 instances running all the time. So even if somebody wants to shop at 3 a.m., they can still do it because there are instances running. There's all code and everything still running. But that's not high capacity traffic for me. Okay, my high capacity traffic is something that comes in the middle. Okay, so that's when instances will increase automatically and then come down. Now there is no this auto scaling, since it is happening on matrices. This matrices can go up in the night too. Example, I have a midnight sale. So in that at that particular point in time, even in midnight, my sale is going to increase, or there's going to be high traffic expected. So in that time also, automatically auto scaling will come into picture and will increase the number of instances. Okay. So if you see here, horizontal scaling is, I had one server taking care of all the traffic. Now I have three servers, a pool of servers taking care of all the traffic. So effectively, I had one CPU, 8 GB, and 1 TB SSD. Now, since I have three instances with the same capacity, it is 3 CPU, 24 GB of RAM, and 3 TB SSD. So this is horizontally scaling, increasing the number of instances, increasing this way. In vertical scaling, earlier I had one CPU, 8 GB RAM, and 1 TB. Now I increased it to dual core 16 and 3 TB. Then I increased it to quadruple. I increase the instance, I increase the server capacity. Okay. So this is how it looks like basically. Smaller instance and a bigger instance. It's very similar to you going and buying an ice cream. Now you buy one big ice cream tub, or you buy small cones of ice cream, like a small cone. Okay. In so that is vertical scaling when you take a tub, horizontal scaling when you buy multiple small cups. Okay. You can go ahead and read the advantages and disadvantages too. Okay. Advantages with horizontal scaling is you can easily scale up, scale down, like very less downtime. You have backups. You can like take care of cost also in this case, because your instance, when you don't need it, you can just release that instance. You don't have to keep it. While in case of vertical scaling, once you have updated the instance from one CPU to dual core, you cannot go back until unless you switch back to the previous instance. Okay, so scaling up and scaling down in case of a vertical scaling is something that's very difficult. So sometimes when it becomes difficult. Okay, I'll tell you around this. Where is it? Okay, it has increased performance. It is fault tolerant, as in because you have multiple instances, so you have less risk of losing the data and all. Okay, fewer downtimes because one of the instances, example, I have horizontal scaling, I have two instances running. Even if one goes down, I have the other instance still keeping the traffic up. Okay, it can be slow, but it's not down yet. Okay, and scaling is easier in case of a hardware perspective. Example, I have this much hardware, I bring up another hardware and make it a pool. Okay, so that is easier. Now when I have this hardware, now I have to increase the hardware. What I do is, I have this hardware, I increase the hardware, install everything here, all of that nonsense. Okay, it increases the complexity of like maintenance and operations. Why? Because you have more number of instances, you have more hardware, you have more software to run. Okay, example, if I have auto scaling and I have 10 instances running, I need to make sure that all of those 10 instances are healthy, all the correct application are running at correct place, and so on and so forth. So I have to make sure of all of these things. Okay, now in case of vertical scaling, it is cost effective because I already mentioned here you will get the full capacity, because a small part is used in operating system, rest everything you are getting. Okay, while in plus maintenance costs are less because you are only maintaining one instance. Okay, even if it is big, it is only one. Okay, it is less complex. Maintenance complexity is less, and software changes you'll have to only deploy it at one place. Here you'll have to deploy it at multiple places. So sometimes it is difficult also. Like there is a possible downtime if there is a failure of this instance, gone. Single point of failure, upgradable limits. You can increase your A CPU from one CPU to quadruple, sorry, to dual, dual to quadruple. Okay, and some levels maybe, but you cannot increase it to infinite level. In case of horizontal scaling, you can add as many instances you want. Make it a pool, let it run. Okay, so generally, in some cases, vertical scaling makes sense. Okay, when you are okay to trade off with these things, I'll tell you. When you are okay to trade off with these things, if example your instance is it's okay sometimes if it goes down. It's not like even if it is a single point of failure. Example, Jenkins. If I'm running Jenkins and I need more capacity, I would not add another Jenkins instance and run it there. Okay, I'll vertical scale it and let it run, because Jenkins doesn't actually directly impact the business. Okay, it will impact just delivery in some way or the other, but it will not impact business. Okay, so it is okay in that case. Okay, it's not like completely okay, but a single point of contact, a bit of downtime, a bit limitations is fine. Okay, example, now you have same as MongoDB, which is taking production data, which has production data, or MySQL, which has production data, and that goes down. You don't want to do that. So there you will prefer horizontal autoscaling. So if you are okay to trade off with these things, okay, then vertical scaling is good. But if you are not okay, okay, if you want high availability, full no downtime, etc, 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 then avoid using vertical scaling to that extent. Okay, because you are anyways creating a single point of failure. Okay, plus there can be other restrictions too, that okay, I don't have that much capacity right now, or I don't have that much initial cost right now to invest in this. Example, now when you have to design horizontal auto scaling. Example, how will deployments happen, how will softwares be deployed, how will I provision new instances, how will this instance and talk to this instance, how will like if I'm writing on or if example it is a machine, it is an application that deals with data. Okay, then it is writing data, this application or this instance which is running is writing data in this. Okay, there is another instance which is writing in this, then there can be mismatch in the data. So we have to take care of data replication, other things and all of that, which is something that you can easily trade off in case of a vertical auto scaling, because if there's only one instance, there's only one data, there's only one service running, there's only one data like file system where data is getting written. Okay, now any questions so far? It is a very very important and very interesting topic, I must say. Okay, I don't think we have enough time to cover like the entire auto scaling concept like in AWS, but we understand what the difference is. Okay, example, I launch an instance, I make it as Ubuntu T2 micro DevOps course. I create a, like I'm giving you example of horizontal vertical auto scaling, okay, or horizontal auto scaling. You guys tell me, okay, whether it is horizontal or vertical. Okay, launch an instance. I've created a T2 micro instance here. T2 micro. Now I want to increase it. Wait, let me try to get the instance type documentation. Basically, I was trying to go in this and see, show you around all the instance types that are available. T2 micro. Example, I have a T2 micro machine and I want to increase that machine type to basically T2 medium, which means I need more capacity. Okay, I'll show you around. I have T2 micro machine and I want to increase the capacity of the system. Okay, I want a T2 medium now. Okay, this is not going through for me. I need a bigger machine. So what I do is I come here. Waiting for it to be stopped. So from T2 micro, I want T2 medium. One CPU is not working for me. I need to make it dual CPU. Okay, dual core. It has stopped now. From T2 micro, I am updating it to T2 medium. Changes will apply, and I then start this instance now. Now tell me, what did I do? Did I do horizontal auto scaling or vertical auto scaling? You can give me answers on chat. Okay, I'll give you an answer. It is vertical auto scaling. Okay, why? Because I increase the capacity of the system. Now, in case of increasing the capacity of the system, it makes sense if my single instance, example, if I'm running Elasticsearch and the minimum capacity that Elasticsearch needs is 12, is 16. In that case, I cannot implement horizontal scaling. Even if I want to, I cannot. Okay, because my application itself to start it needs 16, so I cannot have 8 year and 8 year. Okay, I will have to have 16 year and 16 year, and then it is vertical scaling and auto scaling and horizontal both. Okay, so why? Because vertical, why? Because I have increased the capacity from 8 to 16 of one machine, so it is vertical scaling. And since I want to have multiple EC2 multiple Elasticsearch instances running on multiple instances and like a clustered format, then that is horizontal too. So I have when I start from 8 GB to 16 GB, it is vertical. 16, 16, 16, that is horizontal. Okay,